Good afternoon, everyone. My name is Mark. I'm from Phytech Australia, and thank you for joining this webinar for apple growers, where we're here to talk to you about how to make plant-based irrigation decisions. The agenda for the session today will be to take a quick look around the web user interface of Phytech. Then we'll discuss the factors that affect the irrigation demand of your trees, the traditional decision-making processes that most growers employ, and then we'll look at specifically how Phytech addresses this challenge of irrigation, looking at the three parts of the Phytech service, the first part being irrigation monitoring, the second part being the Phytech plant status, and the evapotranspiration, the hyperlocal evapotranspiration, and the third part being the plant status. Then we'll look at the user interface again, both the web-based version and the phone app version, and then take a look at the indicative pricing for the Australian market for this season. Now, I do know we have some attendees from other places in the world. You will need to contact Phytech in North America if you're joining us from Washington, and to get pricing for your region. And then finally, we'll finish with a summary and opportunity to address any questions that arose. Just to take a look, first of all, at the web user interface. So she'll change over to this small Apple demo site for the moment. So this is an Apple demonstration site that we've just got some sensors installed in the Adelaide Hills, and just a few blocks of apples being monitored there. So the web interface is the primary interface for a PC. So there's no special software to install. It just runs through the web browser. So anywhere that you can get an internet connection and get online onto the web, visit the Phytech website, put your username and password in, and then access all of your data and information. It's very simple. It's just a background layer there that is a satellite photo just from Google Maps. I can zoom in and out there just to see the Adelaide Hills region, and over that we lay a geospatial layer of polygons for the blocks that we're monitoring. So just for these two blocks here, we have a boundary around each block, and then we colour the block with the plant status of the trees that are within that block. So the different colours that we use are shown here. So red for high stress, orange for mild stress that just slightly affects yield, yellow for low stress, and light green for the optimal state, and dark green for saturated or a potentially saturated state when there's more water available to the trees than what they need. So they're the five colours that we would colour those polygons. Today we can see it's going into dormancy now. We're at the end of May here in Australia, so the trees are losing their leaves, so not much activity. They're in a pretty happy state as they go to sleep for this season. We can click on a block to open the data for that block. I've defaulted there to come back in time, but we can just the current period, it's all dark green as the current time of the year, but we can go back in time and look at an earlier time of the year, so back again to that end of December, start of January. We can move up and down the timeline using the arrows there and look at the status that was applied for each day there in the history. So and also open this window a bit further to see some of the actual plant data that's coming in from that block. So there's a lot of information shown here on the screen for this period in late December, early January. This would be the equivalent of late June or early July in the Northern Hemisphere. And irrigation data shown here on the timeline, these blue bars, I can hover the mouse over it. We can see the duration of the irrigation as well as the pressure in the system, a longer irrigation event shown up there. And the graph underneath is the data that's coming from the trees in that block. And from that, we're deriving this plant status, this colour that we'll explain to you today. We also have another number shown underneath each colour for each day is the evapotranspiration rate for that day. So different days have different evapotranspiration depending on the weather conditions of that day, ranging 6.53 millimetres, 9.16 and down to 2.17 on the far side there on that dark green day. We also have a forecast of evapotranspiration because ultimately you need to make your decisions in advance. So a little pop-up window there with the forecast of evapotranspiration for the next 4 or 5 days. That's just a quick overview of the user interface. We're going to come back to that later, but what we'll do now is look at the factors that are going to affect your irrigation decisions. So back to the presentation. And so the typical factors that affect your irrigation demand of your trees, primary one being the weather, and then there's a whole bunch of others. And these range from phenological stage of the trees, the variety, the age of the trees, the fruit load. So more fruit on the tree is gonna require a higher level of irrigation, and you'll see exactly why in the Phytech data that happens. The only time really that changes from one day to the next is when you're harvesting, you know, when you release the fruit load on the trees at harvest time. The canopy size and shape, so how you've structured your canopy or pruned your trees is going to affect how the light intercepts it and therefore how much water they're using, the soil characteristics and the nutrition. So you'll notice with these factors, we've used a padlock as a symbol for each factor. The factors that have a locked padlock are phenological stage through to nutrition. It's deliberate. These factors don't change from one irrigation event typically to another. So when you're making one irrigation event for today, the last irrigation event might have been earlier today or yesterday or the day before. These factors generally aren't going to change in a short time frame. The only one being, as I said, once a year, that fruit load, as you harvest the fruit, you will change that in a short time frame. But the rest of these phenological stage changes gradually over time. Obviously, the variety shouldn't change at all. The age changes gradually. So the one factor, though, that does vary significantly between irrigation decisions is the weather. And so that's really the one that we're trying to make the decision in each block for. So if we could understand from the trees if we could monitor the trees and understand their phenological stage through to nutrition, then if we see a change in behaviour of the trees, then it will be relating typically to the weather. That's the factor that is changing. So they're the typical factors affecting the irrigation demand. The Phytech service, we've been delivering this for a number of years into the apple industry around the world, both in Australia and North America. And when we talk to our growers and ask them the typical approach that they have to making their irrigation decisions in the past, those reasons typically fall into 4 categories, ranging from the climate, just basic weather forecasts, temperature, etc., through to more detailed climate analytics, looking at the evapotranspiration rate and maybe even a crop factor or a KC. We're going to come back and explore that one a bit more. We think there's some merit in that one here at Phytech. The soil, either looking maybe with a dig stick or by putting the soil in your hand and squeezing it, feeling it, looking with your eye. Also, this is typically where many growers have deployed their ag tech budget, so to speak, in deploying soil moisture sensors. So the soil moisture sensors are monitoring a small amount of soil in a block, very, very small amount of soil, and maybe giving an indication of the level of water that's available to the trees. However, it still means that we've got to make a guess at whether that amount of water is the right amount of water for the trees. We still have a guess involved in using soil moisture sensors. We can look at the plant itself. Many growers, of course, if they see signs of wilting or yellowing, they know that maybe they need to irrigate more. Ideally, though, we want to avoid these, and similarly, some of the recent advances in imagery, satellite imagery or drone imagery, that claim to detect stress in trees, it is possible to do that, but of course, it'd be much better to avoid that stress in the first place. So using a drone or looking around the orchard, waiting for the signs of stress to appear, is not good for business. It's not optimal for the trees to enter that stressful state, and so it'd be much better to avoid them if we can in the first place. One method that perhaps can identify stress earlier, or the amount of water in the trees, is a pressure bomb method, or otherwise known as midday stem water potential. However, this method typically isn't economically viable to deploy across an orchard operation in a commercial sense. The device and the hardware are very expensive, time consuming to use, and there's only a narrow window of the day that it can be used. So if you're making irrigation decisions every day for multiple blocks, it's just not feasible. On the human side, we have, of course, knowledge and common sense. If it's a hot day, you might apply more water than a cold day. And then finally, the experience factor. And this comes through trial and error. Each year, you make a decision maybe to change your irrigation practices to irrigate a little bit more than you normally would, or a little bit less. You get to the end of the season, you harvest your fruit, and perhaps you see a difference, perhaps you don't, but you still have to wonder whether there were other factors that might have affected that outcome. And so that you need to repeat that over several years. And that's why generally it takes many, many years to gain that experience. For many growers that have decades of experience, they'll quite often admit that the decisions they make today are very different to the decisions they might have made 10 or 20 years ago. Now, it's not, some of those decisions might be due to the change of how they're growing, but it's typically through that experience, through trial and error. At Phytech, we also believe there's value in this, but ideally we think that we need to change the learning loop from 1 year or one season down to 1 day, or between irrigation shifts, potentially, if you're irrigating every few days. So there is a chance to improve this experience if we can get better feedback in a shorter time frame, rather than waiting to the end of the season to see the crop come in. So at Phytech, the first part of the service is irrigation monitoring. And to monitor the irrigation, we use an automated irrigation sensor. This is a pressure transducer that gets installed in the orchard, in the block, into the drip line or sprinkler line. Any pressurized irrigation system it can be fitted to, at a resolution of 1 per valve. It's a wireless sensor. It has batteries. It doesn't need to plug into mains power or to a solar panel. It has a few batteries. They last a few years, and this checks for pressure in the irrigation circuit at the dripper level or the sprinkler level once every 10 minutes or so. And if it detects pressure in the system, if it's above about 50 or 60 kPa, then we record that the irrigation is on. So effectively, over time, we're recording the duration of your irrigation events. We convert the duration of your irrigation event to a millimetre amount, or acre feet, I think in North America is the term of use. We convert that to millimetres using a unique factor for your block. So looking at the emitter spacing or sprinkler spacing, the row spacing, and working out how many millimetres of water you're applying each hour. Also, this sensor once an hour records the actual pressure in the system if it's irrigating, and reports that back to our servers. So this is all happening automatically. There's no data entry. We don't ask you to get your keyboard out and type in when you turn the water on and off. We don't rely on an API or connecting with an irrigation controller software to do this either, because there's always a chance that you have a blocked filter or some other communication issue that might mean that the irrigation isn't happening according to the plan set by the controller. That's the first sensor that we deploy in the orchard, and the data from that sensor comes into the servers and displayed on a timeline. So this is just an example of a 5-day period from March 24 through to March 28. And data comes in and sits on the timeline relative to the position or the duration of that irrigation event. So the wider the blue bar, the longer the irrigation event, and the position of the bar on the timeline is important too. So the Wednesday, Thursday, Friday irrigation events were later in the day, closer to that midnight marker. The irrigation event on the Saturday sits in the middle of the day because that's when the irrigation happened. We also deliver that irrigation data to the smartphone app, and this is from a different block, but just showing the little blue bars again for the days that we're monitoring. Small blue bars show up there relative to the time and duration of the irrigation event, and we can click on those and see the exact on time, off time, duration, amount applied, pressure in the system. So this is just a partial screenshot from our smartphone app. If we're monitoring multiple valves in an irrigation or in an orchard area, then our system applies some simple machine learning to determine your irrigation patterns. So if you have irrigation shifts that come on, so if valve 21 and valve 22 typically come on together and get irrigated at the same time, our system sees that and learns it. Then one day, if valve 22 doesn't turn on when valve 21 does, then that will trigger a deficient irrigation alert. Just to alert you that maybe something went wrong there, maybe a blocked filter. Similarly, if valve 22 if the irrigation gets stuck on and valve 21 is turned off, then the system will create an over irrigation alert to alert you to perhaps a valve being left in the on position. So that's just a very simple application for the data. The other application that we use for assessing the data is the pressure. So we're monitoring the pressure for these irrigation events. We calculate the median pressure over the last 10 or 12 hours of irrigation, which may be one event of 10 hours or 10 events of 1 hour. Calculate the median pressure over that time. And then if for a new irrigation event, if we see that the pressure drops 20 or 30% below that median, then that will also trigger a low pressure alert, as well as if the pressure drops below about 60 kPa. So that's just using some smart analytics to create low pressure alerts to alert you perhaps to a filter that's getting blocked, or maybe too many valves turned on at once in an irrigation system. So this is all just from that irrigation sensor that we collect this data and deliver it. And in its own right, it does deliver significant value to the operation to know that irrigation is coming on and off when you intended it to. The second part of the Phytech service is evapotranspiration calculation. So these are done for turf. Turf is used as sort of an industry standard because it's a two-dimensional crop. It's evergreen. It doesn't have we don't have to worry about row spacings. It's shallow rooted. Doesn't have a fruit load. We keep it mown every few days. So we calculate the theoretical loss from your operation as if you're a turf farm, basically. The evapotranspiration is the sum of water lost to evaporation from the soil. Some people know that as evaporation pans, but also the water lost from transpiration from the plant itself. And so the sum of these, and it's calculated hourly using the cumulative effects of temperature, relative humidity, radiation, and wind speed. So for each hour of the day, look at the temperature through to wind speed for that hour of the day, calculate the evapotranspiration, evaporation and transpiration, and then sum the 24 numbers together. We get a daily figure given to our Australian clients in millimetres, given to our North American clients in inches. The Phytech service uses a proprietary algorithm to calculate this. So there are some known published algorithms. Most widely used is the Penman-Monteith method. At Phytech, we used to use this algorithm, but found that there were distinct issues with using it in comparing it with tree crops. And so we developed our own algorithm effectively using data from trees to determine a new, more accurate algorithm that can be applied for orchard operations. And the data that we use, the weather data that we use, is hyperlocal, meaning it comes from a third-party source, a model source. We use IBM or the weather company to deliver that data to us. So for your orchard operation, we give the weather company, which is owned by IBM, the GPS coordinates to your operation. And then from there, we buy a forecast as well as a historical record of your weather factors, those factors I mentioned earlier, for every hour of every day, 14 days in advance and 3 years of history. And that helps us then to develop a specific forecast and calculation for your operation. Now, to make that relevant, that turf evapotranspiration number relevant, we either need to know the tree spacing, the variety, the size, the age, the phenological stage, the fruit load, the canopy design, etc. And to understand all of these things and to factor it in is virtually impossible. Some research organisations have tried to do it maybe just based on a variety and an age, but not factoring in all of these factors. So if you are familiar with using KC charts or crop factors, they might factor in part of this, but not all of it. So at Phytech, to get it really accurate, we believe the best way is to monitor the trees and let your trees tell you what that ratio or what that factor should be. So the calculation that we make is given historically, but also as a forecast, and that's important that you have an evapotranspiration forecast. If we were using weather stations deployed in an orchard, the problem with a weather station is that it will only record the history. It won't tell us what's happening later today or tomorrow. There's no such weather station that exists. The only source for forecast information is those serious companies like IBM that have the computer power to do the modelling. And so at Phytech, we have that forecast, that calculation given for your operation. And the example that we see here is for an orchard in South Australia for last year. We see some different values there, different days, different temperatures, but also more importantly is the varying number given in millimetres there, ranging from 5.84 millimetres through to 9.71 millimetres. That's the second part of the Phytech service. The third part of the Phytech service is the plant status. So if we just recap the first parts, we know how much water you've applied in millimetres by monitoring your irrigation. We know how much water you theoretically lost based on a turf farm application. And now we monitor the trees to understand if you're getting that ratio right. And so the sensor that we use to do this is called a dendrometer. It's a sensor, in this case, as it's shown in the screen there, it screws into the heartwood of the tree using a stainless steel screw, and then it measures the change that's happening just underneath the bark in the xylem, cambium and phloem layers. And these are the layers that deliver water from the root system up to the leaves and also act like a reserve, like a tank in the tree, holding water for it to operate during the day. The accuracy of this sensor is 5 microns or 0.005 millimetres. In perspective, that's 1/20th of a human hair. So if you take a human hair, cut it into 20 slivers, 1/20th of a human hair is the accuracy of this sensor. It's taking hourly measurements and the change of the trunk radius, and we'll typically monitor 3 trees in a block. So the first tree we monitor is just to make it work. The second is to give us statistical confidence. And the third is for redundancy, that if the batteries go flat in one or an animal bumps it or something else, that for you as the customer, there's no problem with the integrity of the service that we're delivering. You continue to get the service. That's the sensor that we're using. So how that is calculating the plant status now. We use this pictogram to describe what's actually happening with the tree during the day. So on the left side that we have the daylight hours, 6 a.m. through to 6 p.m. and the right side of the screen, the evening hours, 6 p.m. through to 6 a.m. So during the day, first of all, I should say, we have to install our dendrometer. There it is, put a dendrometer on the tree. And then during the day, the sunlight activates the process of photosynthesis. So opening the stomata on the leaves, the pore on the leaf, and the water inside of the leaf evaporates out to the atmosphere. It's a necessary process because that stomata that's open on the leaf needs to be open to let carbon dioxide in. We need the carbon dioxide as a building block for making sugars and carbohydrates. So the water is being lost through the leaves there during the daylight hours. Also during the day, if we've got fruit on the tree, the water moves from the leaf tissue and from the trunk tissue and branch tissue into the fruit itself. And this is part of the way that the fruit accumulates the sugars that were created in the leaves. The leaves are creating the sugars. They've got to move some way or another from the leaf tissue into the fruit. And so part of that is through solute process of dissolving it, but also it's actually a mechanical shuffling the water from the sugar-laden water from the leaves and tissue of the tree into the fruit itself. And so we see that the more pieces of fruit you have on the tree, the fruit load, the more pieces of fruit that are going to be taking that water from the tree during the day. It's not all doom and gloom though. The tree can, if it's got water available to its root system, it can partially sustain itself, and so it takes up water through the root system to try and maintain that loss. But for most apple species, on most average growing days, they lose a lot more water than what they can take up. So they're not 100% efficient in this case. They're losing more water to the atmosphere and to the fruit than what they can actually take up through their root system, even if there's plenty of soil moisture available to them. So during the day, then what we see is a reduction in the trunk diameter or the trunk radius measured by our dendrometer on the tree there, and the amount of contraction is relative to the productivity of the tree. As each hour passes and it contracts further, we get closer to reaching the wilting point. That happens when it completely runs out of water. But as we lose each little bit of water that gets lost, we get closer to reducing the productivity. So Phytech, we've analysed this and written our algorithms for apples to identify when the apple tree is losing about 10% or so of its productivity. That's going to trigger an orange alert, and when it's losing 20% or more, that's going to trigger a red alert to you as the grower. Now, the red alert there coming up at a 20% reduction is well before you see any visual signs or your drone can see any visual signs of stress. The wilting point is about 100% loss of productivity. So this happens very, very early as far as the identifying the very start of when the productivity of the tree starts changing. And that's the first attribute of the data that our system analyzes to determine the status of the tree. As evening passes, or as we enter the evening period now, the fruit gives its water back to the tree without the sugar. So it's taken sugar-laden water in the morning, extracted the sugar from that water, and then it gives back just the water at the end of the day. And so the tree can partially recover just through the water coming back from the fruit. But of course, it is also taking water up through the root system, and it's not losing any to the atmosphere at night. There's no sunlight for photosynthesis. And so effectively we have all things helping us to moving in the right direction to help us recover. And our dendrometer mounted on the tree. If we have good soil moisture available, then we're going to see a full recovery. And that's the second metric, that the key metric that our system is analysing and looking for, is that the tree finishes the day as good or better than when it started. Now, if there's a lack of moisture available to the tree, so a different scenario here, if there's less soil moisture available, then we're going to see a failed recovery, and even less again, and the recovery is going to be even worse. So the recovery of the tree and the rate of recovery is a good indicator of soil moisture availability to the tree. So in this case, if it doesn't fully recover, that might trigger an orange or a red alert as well for that day. So there's other factors that Phytech look at, but they're the key two factors that determine the colour status that's shown for each day. Now, to bring all those three pieces in together and to show you how we can make that learning cycle a lot quicker or a lot shorter, this is our timeline again back in March. We've got the evapotranspiration data shown there below the date, so 2.2 millimetres on Tuesday, up to 5.9 millimetres on Saturday. We'll bring in the plant data first. So this is the data from 3 trees, and we can see distinct differences in the behaviour. On the Tuesday there, the low evapotranspiration day, there wasn't any contraction of the tree. On the Wednesday was a medium contraction. On Thursday, Friday and Saturday, we had small contractions. And so, as I said, we've got a full recovery each day, so that's not really a factor, but the size of these contractions is in this case what's driving the different colours. And at this point, you'll see that without any contraction, it triggered a dark green status. And many growers will recognise that too much water can stress a tree as much as not enough water. And the beauty about using a dendrometer to take this measurement is that those two issues are at opposite ends of the spectrum of our measurement. So if there's too much water available to the tree, then we don't see any contraction at all. If there's not enough, then we would generally see a much larger contraction. So the light green status there shown with the small contraction is the ideal status that we want to achieve. We can bring in the irrigation data and show you then how the grower irrigated for this period. So the Tuesday there was no irrigation applied, and it showed that the tree didn't need any. The dark green status of showing a saturated state doesn't mean that the block is underwater. It just means that there's more water available than what the tree needed for that day. It shouldn't surprise us. It was a very low ET day, and so there was probably very little demand. The Wednesday there, much higher demand. The grower irrigated that afternoon, and for many clients initially that might trigger a question about, well, I've irrigated late in the afternoon, but I still see an orange status for that day. And the reason is the timing of the irrigation. It came too late in the day after the contraction had already taken place. So if we look at the timing of these irrigation events, we can see that on Wednesday, it was after the contraction happened. It was probably, the irrigation would have helped the recovery, but it didn't help prevent that contraction. Thursday and Friday, the irrigation was late in the day also, but the evapotranspiration rate was less. It was below 5 millimetres. So in that short time frame, just in those few days, the grower learnt the behaviour of the trees and the irrigation, and instead of applying more irrigation, decided just to change the timing of the irrigation. And so on the Saturday, looking at Phytech, he saw a higher evapotranspiration forecast, 5.9 millimetres, and so moved the irrigation event to the middle of the day during the contraction period, and was actually able to arrest the contraction and keep the tree in a productive state. So in this case, for this grower, it's just a small example of how the Phytech service can help you make better irrigation decisions based on the plant data of your orchard operation. So in short, what's really happening, whether you do it consciously through a mathematical process or subconsciously, it happens anyway, is that you're applying irrigation. there's a ratio of irrigation that you're applying to the actual forecast loss, or the actual loss, that evapotranspiration. And so at the end of the day, the plant holds up a scorecard for you to verify that ratio. Red if maybe your ratio was too low, and dark green if your ratio was too high. And so then you'll adjust the ratio using then applying that to the forward-looking evapotranspiration forecast that we provide, apply that irrigation, and the cycle continues. So we've changed that learning cycle from 1 year down to as short as 1 day. If you're irrigating every 3 or 4 days or so, then you just sum the values of your irrigation for those days as well as the evapotranspiration to calculate that ratio. The other thing that we do for the apple and pear industry is provide a fruit size sensor. So this sensor is installed on the fruit while it's growing in the orchard. It can be installed when the fruit is about 20 millimeters, so about 3/4 of an inch in size. We can install this sensor, and it tracks the fruit growth all the way to the day that you harvest it. Taking an hourly measurement, the accuracy of this is less than our trunk sensor, just with the way the apparatus is designed, but still plenty accurate enough, an accuracy of 0.1 millimeters. We also monitor three pieces of fruit in a block, typically one on each of the 3 trees that are being monitored, and then we average the data from those. So it's not really designed to replace your need for taking maybe fruit size measurements for marketing purposes, but of course it can help you understand how your irrigation actions and your plant health are affecting the growth rate of your fruit. So with that, I'd like to perhaps get into a bit more scientific detail and have a look at an example of the apple behaviour that we see between the tree and the fruit. So the period that we're going to look at is the start of January, the equivalent of the start of July for North America, and we're looking at a 1-week period. And here's the data from a 1-week period. We have 7 days there, Thursday, Friday being yellow, Saturday being red, some dark green and some light green days. That's the data that's come from the trees in that block that's then determined that plant status, that colour that you see. The fruit size data from the same block for the same period looks something like this. There is a scale on the side there, it's probably a bit hard to see, so we'll bring a larger scale in here just to show you. They're not on the same scale, so the day there, Friday, the change in the trunk contraction or the size of the trunk contraction was about 200 microns or 0.2 of a millimetre, and on that day we saw an expansion of the fruit of about 0.8 millimetres. Now, just to highlight that, this is then, if we presuming that the tree is recovering, we can see it recovered at the end of the day. This sort of colour chart here gives an indicator of how that yellow status came about. It's where the tree finished the day there in that yellow before recovering. Interestingly, looking at the behaviour of what's happening between the tree and the fruit. Remember I said to you that the fruit expands at the start of the day when the trunk is contracting, and here we can see it in real time really with this data. So from 7 AM there, the trunk is contracting and the fruit is expanding. As I said, the water, that sugar-laden water, moves to the fruit at the start of the day. This day here, the red day, the colour chart gets reset a little bit to the maximum height there. It moves up a bit just to allow for the growth of the tree, and we can see on that day that by 1 PM it had dipped out of the yellow and into the orange, and it finished the day in the red. So looking at then the behaviour of the fruit, we see that from that period of when it dipped into the orange, the fruit started contracting. And that means that it's taken the water at the start of the day. It's extracting. It's doing its job of extracting the sugar, from that water. But at this point, the tree has become a bit too stressed and basically starts asking for that water back. So it starts automatically taking it back from the fruit, whether it's removed all the sugar or not. And so that's an explanation or reason why or how we're losing productivity on those days. The previous day, the Friday, just to show the 1 p.m. time, we were well and truly in the green there, and you actually see the difference in what the behaviour of the fruit. Because the tree wasn't stressed, it didn't need the excess water, and so it was happy to leave it in the fruit, let the fruit remove the sugar before asking for it back at the end of the day when the stomata closed. So we had a few extra hours of production there, effectively, of the tree. Also of note from this example, this was a great example, we see that there's a couple of dark green days, and the behaviour very different on those days. So on these days there was a small amount of rain, the evapotranspiration was quite a bit lower, so there's probably a fair bit of cloud cover around, therefore we can expect less activity in the trees. The irrigation that was applied probably really didn't need to be applied at all. And we can see then what's happening with the fruit. So this was rainy days, but if you were achieving this dark green result through over irrigating, which is another way of getting to that dark green, then this is another reason why you are harming your productivity. So too much water is also going to reduce the productivity, as we see that the water isn't moving into the fruit as much if the trunk isn't contracting. So another justification for getting the irrigation right. So the Phytech service, those colours are delivered through the interface. We see this in this example. I took this screenshot a month or two ago from the Centre of Excellence Orchard and Almond Orchard in South Australia. That's a demonstration site for our service. And we see that each block has a different colour there. And your eyes get immediately drawn to the blocks, obviously, that are red or orange, and so we know from what we've seen now that the light green status means that the trees are happy with the amount of water that they have available to them. Now the Phytech service is relevant not just for apples and pears, but for a whole bunch of crops. So if you do have a fruit salad or a fruit and nut operation, the Phytech service can be deployed in multiple crop types. We apply different algorithms to different species and even different varieties, but you can see everything in the one screen. We'll jump now and have a look at the web interface again. So this was our example, the apple orchard. I'm going to change to a different example. Actually, just change over there. This is the Centre of Excellence Orchard. In South Australia. I'll pick this one just because there's more blocks to look at here. So the current status today, as these almond trees go into dormancy, 27 light green blocks and 2 dark green blocks. I wouldn't read too much into it at this time of the year, but each of these blocks we have sensors on the 3 trees and on 3 trees in that block, as well as the irrigation system. There might be 1,000 or 2,000 trees in a block. We use perhaps satellite imagery as a starting point to work out the median location of where to put the sensors. Other than that, we'll also ask the grower for soil maps or irrigation infrastructure maps, topography maps, and then effectively ground truth it as well to find 3 median trees in that block to deploy the sensors on. We can click on a block, as we saw earlier. Click on a block and open the timeline there. We can see the moment that I might be doing some late season fertigation. We've got the irrigation events showing up there on the timeline. So I'll go back to earlier in the year. Go back to near the start of January there. Just looking at that period. We'll go back a week there, so we can just see some different colours. So we've got the irrigation data showing on the timeline. If you're irrigating multiple times in a day, then you can see the individual events as well as the sum of the total for that day shown at the top there. Also got the pressure, of course, of the irrigation system shown for each event. The trunk data shown here that's driving the plant status colours in the line above, and that evapotranspiration value given for each day. Now I can move the map up there a bit, click on another block to see how that behaved for a similar period, click around, see different blocks and how they're acting. We also have a summary view called a plot list view. So click on that down the bottom of the screen here, and we'll go back to that same period earlier in the year. And let's scroll down to here. I know there's a few things around this area to look at. So we see some irrigation issues here. The irrigation was stuck on overnight. So the irrigation controller software, there was a glitch in the software or in the command sent to the valve. The irrigation turned on in the afternoon when the irrigation manager was still there, and turned off the next morning just before he arrived. So when he arrived, he would have seen that his water meter had been ticking over all night, scratching his head. Without Phytech, would have had no idea where that water was going. His irrigation controller showed him that the irrigation wasn't on, when in fact 3 of these valves here had been stuck on all night. We can see that the irrigation events, as I said, fit on the timeline the same as we saw them earlier. So different blocks here. If we compare maybe valve 22, the label is just above it. So valve 22 versus valve 23, we see a difference in the plant status. They're both getting irrigated together at the same time, I'm presuming on the same shift. But we see that valve 22 is getting a few yellows and a red day here versus dark green on valve 23. So possibly for this grower, there might be an opportunity to reduce the duration of the irrigation in valve 23 and maybe increase it in valve 22, or put them onto different shifts. The total evapotranspiration is shown at the top banner for the week. So each day we have the evapotranspiration rate. It sums to a total for the week. And then below that, for each block, we have the total irrigation in millimetres for that block, and then the irrigation to ETO ratio. That ratio that we talked about earlier is shown here. So 0.41 is what comes when you divide 24 by 60. And so that ratio can then be used going forward. If we get too many dark green days, we'd probably want to consider reducing the ratio. So that's a quick look around the web-based user interface. And what I'll do now is attempt to share my smartphone screen. And there we go. So the Phytech plant app is what we use. If you have multiple orchards, then you can sort of list them here. This demo login, I've just got 4 orchards here. The Almond Board of Australia, that orchard that we just saw, as well as some of these others. Now, I'm actually going to show you the Sunlands citrus block. So it's just a few blocks here. It's got 2 blocks of citrus, Valencia and Navel blocks, and I can look at the map view here on the phone, as well as open this up to look at the record for these 2 blocks on a plot list type view. So at the top, a forecast here, the evapotranspiration of the next 6 days. Underneath that then, or on the timeline, we have 7 days shown here. So the last active 5 days plus today and tomorrow. The evapotranspiration rates for those days, the actuals for the past and the forecast for today and tomorrow. And then beneath that, the status of each block. We've got some irrigation events shown there that we can open up. no irrigation alerts showing. If we've got multiple blocks, we can sort them by the status, the name of the block, the alerts, if there's irrigation alerts that came in, or by the fruit size. So we'll just click on the navel block here, and what I wanted to show you was a bit deeper in here. This is the overview of the block boundary and the location of where the sensors are in that block. I can click on this and open a graph to look at the trunk status of the last 5 days, and swipe sideways and to see how the fruit growth is tracking. So these navel oranges haven't been harvested yet. The orange graph there is the fruit size. The black line is actually the target size. So at the start of the season, when you put the fruit size sensors on, you can nominate in the system the target size you want to achieve and the target harvest date, and it will draw a trajectory. It's a slightly curved line. The fruit doesn't grow directly or linearly, so it's a slightly curved line. And then we can show you how your fruit growth is tracking to where you need to be for that time of the year. So I just wanted to show you that on this, because for the citrus that hasn't been harvested yet, and we can see that this grower is right on track. That's a quick summary of the main part of the app. We can also sort at the top there by variety. So if we've got multiple varieties, we've just got the Valencia, of course, one Valencia and one navel. We can toggle between those to see to compare them. In the settings for the app, we can choose whether we want irrigation shown by amount or duration. Choose whether you want the water pressure shown in kPa or PSI, and then you can also turn on a range of push notifications. So these are like those little text messages that pop up on your screen. If you're happy to get them from our service, you can turn them on in here. So turn on a notification if a block is stressed. Turn on notification if there's an irrigation alert, low pressure or over or under irrigation. And you can even turn on a notification just to get notified whenever an irrigation block or valve turns on or off. And finally, down the bottom there is an option of colorblind mode for those that need it. So that's the Phytech app. For both of these apps, or the smartphone app and the web browser app, everything is read-only. So there's no way in here that I can delete the data or change the data. I can just log in and view the data. So everything is, all the data collection is automated, the analytics is automated, and it's all read-only. So that's the smartphone app, and I'll come back to the main screen. So just to summarize that, Phytech is a plant-centered decision tool using data from your trees, your irrigation, and your weather. It's customized for your operation. It is a true software as a service model, meaning there's no investment in hardware. All of those sensors that we showed you and the data loggers, which we didn't show you, but are there collecting the data from the sensors, all of that hardware is owned by Phytech. We don't ask you to buy any of it. We retain ownership of all the hardware we install in your orchard operation, so that if anything happens to us, or you change your mind, or you decide that you want to go in a different direction, you haven't wasted any money on hardware. So there are a number of other companies that offer what they call software as a service, but also ask you to pay for the hardware, and they're probably the models to be most wary of. It's an all-inclusive service, so there's no additional hidden costs. It's as many logins as you need for your operation, as many hours that you want to look at it, and as much support that you need to derive that value from it. It's in our best interest to help you, particularly in your first season, because if you don't retain the service, then we lose the money of all the hardware that we've installed in your operation. So it's in our best interest to ensure that you get the value out of it. It's fully automated, so there's no data entry. You can put the keyboard aside. All of the sensor data comes into our system automatically. It's analyzed automatically. Algorithms are applied automatically, and then it's delivered out to that web browser or your smartphone automatically. It's also a closed system, so there's no way that you or any of your staff can delete or alter or change any of the data. So if you lose your phone or somebody steals your computer, there's no problem for your Phytech data. You just need to log in again from a new device or another device, and everything will be there for you. So that's a summary of the Phytech service, and I'm going to open it up to questions now. So if you have any questions, please feel free to type them in, or alternatively, there is an option to raise your hand. We'll address the written questions first, and then if you want to raise your hand to ask a question, feel free to do that now, and we'll unmute the mic and address it. So I'll just look at the first question we've got here. So first question here is, early on in the season, we tend to irrigate because we're told the trees require water and there is bud burst, etc. happening. We also put fertilizers out at this time. Do you see in the data that this is the right thing to do? Okay, so that's a good question. I'd like to point out, first of all, that we're not calculating whether or not you need to apply a fertilizer. This is helping you with irrigation decisions, but obviously a lot of growers apply their fertilizer through their irrigation in the form of fertigation. What I'd suggest is that at that early time of the year, when many growers are applying fertilizer during bud burst or flowering, if there's no leaves on the tree, there's no photosynthesis, then there's really no activity, no way the plant can take up water. So many of our growers that are using our service are changing the way they're applying their fertilizers, realizing that applying them at bud burst or flowering, if you're applying them before you've got a reasonable sized canopy, then if it doesn't sit in the soil and waiting for the tree to be ready, then you're going to lose it. So yeah, we can see that through the plant behavior the right time to apply fertilizer. Thank you for that question. I'll just see if there's no other written questions. If anybody has any questions they want to ask, if they want to raise their hand, I don't see any there. All right. Well, I thank you for joining us today, and please, if you're part of an operation, we have another Apple webinar coming up next week. So look on the Phytech website if you've learned something out of this, or you think other people in your organisation will. Please feel free to recommend them to the next session next week. Thank you for joining us, and bye for now.